Okay, welcome back. We're going to have a look through some more of our 2D shape problems today and look at how we can identify what we need to do and how we can solve them. Our first one's asked about Anna and had 4 different triangles. She's got 3 isosceles and a right angle triangle. In our isosceles triangle, we need to know that 2 of the angles are going to be the same and 1 of them is going to be different, but all 3 angles are going to add up to 180 degrees as they will in any triangle. Okay, the other thing that I can spot here is a right angle triangle. All of my angles in a right angle must be a right angle, must be 90 degrees. This one's not, so I know that that one's going to be. Knowing that all angles inside a triangle must add up to 180, 90 plus 80 gives me 170, which means my angle 3 has to be 10. So we've dealt with one of them. Let's have a think about these isosceles then. The first one has got an angle 1 here of 90 degrees. Now, I know that has to be the angle at the top, because if I had 2 angles at 90 degrees, that would give me 180, which would mean I wouldn't be able to make a triangle out of it, because I'd already used up all of my angles. So it's going to look something a little bit like that. Now, knowing I can have 180 degrees in total for my triangle, I've already used 90, which means I've got 90 left. That 90 has got to be shared between angle 2 and 3 here, which means both of those are going to be 45 degrees. If I add those up, 90 plus 45 gives me that 180. Okay, so then let's have a think about what we're going to do with the third one down. This one has angle 1 of 70 degrees. So for starters, we're going to assume that 70 degrees is up at the top again. So if that's my 90, it's going to be something a little bit like that. Now, that's great. So I have my 70 degrees. Again, coming back to my key fact here of 180 degrees in a triangle, I know that what I'm going to have to do is subtract my 70 from my 80, give me 110, and then I'm going to have to share that between my other 2 angles, between angle 2 and angle 3. So 110 divided by 2 is going to give me 55 degrees for each of these. Okay. Now the third way of thinking about this isosceles is that actually that 70 degrees, that's going to be my 2 angles that are the same. So that's going to give me quite a pointy isosceles triangle where I've got 70 degrees here and 70 degrees here. That means that angle 2 can be 70 degrees, and I can pop that straight in. What that then leaves me with is I've used 70 and 70 of my 180 total, which means I've used 140 of my 180, which leaves me with 40 degrees. Question 2. Another nice little table about quadrilaterals. Quadrilaterals, quad, 4-sided shape. These all have a perimeter of 36 centimeters. Okay? So square, easy. All sides are the same. Unfortunately, that's been done for us. Now rectangle. So, if I'm thinking about this, my advice to these would always be to draw them. Just sketch them out nice and quick. So, I've got 3 centimeters. Now, that's not going to be my long side because I have to get to a perimeter of 36. So 3 is going to go here, which means the opposite length is going to be 3. Which means added together, I've used 6 centimeters of my 36 centimeters. Which means I have 30 left. That 30 is going to be shared between my 2 remaining sides, which means that both of those are going to be 15. So I'm going to have a 3, and I'm going to have a 15, and a 15 centimeters. Now, for my rhombus and for my kite, they're going to be slightly trickier shapes to think about. I don't know if I've got a rhombus up here, let me have a look. So, a rhombus. Now, with my rhombus, it's going to be important to think about where these lengths are going to go. Okay, so with my rhombus, things that I know is that I have 2 sides that are the same length. I have a shorter side and I have a longer side. If I come back over here and look at the fact that this is a 9 and my square is 9 as well, I can use that fact to help me. So what I could put here is I could put my 2 leaning insides as 9 centimetres. That would have used 18 of my 36, which will leave 18 left. So if I pop a 9 in here. Now, these can't be 9 because that would just give me a square, and you can see that I have a shorter and a longer. So what I could have is I could have an 8 and a 10. I could have other variations along that thing, but I'm going to pop those in because that's the most straightforward one to do. And that helps me out. Now, with a kite, the things that we need to know about a kite, I wonder if I have a kite, might have to draw a kite. The things that we know about these are that we have 2 sides that are the same length and 2 sides that are shorter. Now, if I had 10 centimetres as my short side, that's not going to work because it means the other 2 sides are going to have to be greater than 10. So that is going to be a non-starter. So one of my other sides, let's say this one here, this is our 10 centimetres we've been given. This one here is also going to be 10 centimetres. I'll have the right way around. Okay, that's used 20 centimetres of my 36 centimetres, which means I have 16 left. That has to be shared equally between here and here, which means that both of those are going to have to be 8 centimetres. Moving on. Question 3. Jamie draws a triangle. He says, 2 of the 3 angles in my triangles are obtuse. Explain why Jamie cannot be correct. Okay, straightforward. So, right angle is 90. We know that. Obtuse must be greater than 90 degrees. Okay, so if he's got 2 angles that are obtuse, that means he's got 2 angles that are more than 90. Then 2 times more than 90, let's say for example they were 91, even if they were tiny obtuse angles, they're still going to give me 182 degrees without factoring in my 3rd angle, which means that they cannot be right because in a triangle I can only have 180 degrees as my internal angles. That's why he's wrong. Number 4. 4 statements. For each one, put a tick if it is possible, and a cross if it's impossible. So a triangle can have 2 acute angles. Yeah, of course it can. A triangle can have 2 obtuse angles. We've just discussed that above. A triangle can have 2 parallel sides. Parallel sides. Lines that always stay the same distance apart. Make a triangle out of that using one more line? Don't think so. A triangle can have 2 perpendicular sides. Well, perpendicular are simply 2 lines that meet or cross to form a right angle. And there's such a thing as a right angle triangle. So we could have that, of course. And that could be my triangle with perpendicular sides. This one is perpendicular to this one because they meet at 90 degrees. Question 5, interesting one, is an equilateral triangle inside a square. Don't know why you would put an equilateral triangle inside your square, but here we are. The perimeter of the triangle is 48 centimetres. Now we know from thinking about perimeter previously that that's a distance the whole way around the outside of a shape. Okay, now if I know that my triangle is this 3-sided shape, I can simply do 48 divided by 3 to find out the length of each side of the triangle, which is pretty straightforward. Okay, and if I know that that's going to give me this length, that's also going to give me this length, and it's also going to give me the length of the bottom. And what you'll notice about this length at the bottom is that that happens to be the length of the square. So 48 divided by 3 obviously gives us 16, which means that the length of one side of the square is 16. The question is asking for the perimeter of the square, which simply is the distance all the way around the outside of the square. Instead of it being 3 sides as it was for the equilateral triangle, it's now 4 sides. So I simply need to do 16 multiplied by 4, which will give me the answer of 64. And that is my perimeter. Number 6, look at this diagram. Calculate the size of angle X and angle Y. So, things that we need to know. Internal angles of a triangle, 180 degrees. We know that that is 90 degrees. We are given that X must be what is left when I have added 35 to my 90. So 35 at 90 is 125. My internal angles in a triangle are always 180 degrees, which means that my angle X must be what's left if I find the difference between 180 and 125, which must mean that angle X is 55 degrees. The second part of this question is asking me for angle Y. We looked at this yesterday. We looked at angles on a straight line being 180 degrees. So here I've got 35, and then here for Y I have whatever else is left that would make me that 180 degree angle. So that's going to be 180 degrees. If I subtract 35 from that, I will wind up with what I have for Y. So 180 subtract 35 is 145 degrees. Question 7 says the area of a rectangle is 16 centimetres squared. One of the sides is 2 centimetres long. What is the perimeter of the rectangle? Okay, so I'm just going to draw it. I would always draw it. One of the sides is 2 centimetres long. It's going to be the short one. To find the area, you need to do length times width. So we did this when we've looked at this before. A equals L times W. So if the width is 2 and the area is 16, what times 2 is 16? 8. 8 times 2 is 16, which must mean that this side is 8 centimetres long. That's not what I need to do to write the answer down. I need to do it to work out the answer, but this is asking me for the perimeter here of the rectangle. Now, if I now know my measurements of my length and my width, P equals 2L plus W. Perimeter is 2 times the length plus the width. So length plus width, 8 plus 2 is 10, 2 times 10 is 20. And then finally, last but not least, area of the triangle. With this one, we talked about the other day our triangles and the area of our triangles simply being half of the area of the rectangle it would take up. So if I had my rectangle like this, and I would probably just draw this on the ruler anyway, so it's there for me to see. If I wanted to find this whole area of a rectangle that I've got here, this whole massive area, well, as we've seen in the previous question, A equals L times W, length times width. But I don't want that area. I don't. I want half of it because it's the area of the rectangle. And actually, we should remember from our revision that the area of a triangle is half of the base times the height, which we also know actually is just kind of the length times the width of that rectangle. I have those measurements here. this one's been included, but actually that's sneaky. I don't need that information. All I need to do is I need to do 12 times 9 base times the height, and I need to half it, and that will get me my answer. I hope that's been helpful. Let me know if you need anything else for these questions.